combustion. The combustion is heating in the presence of oxygen. So taking an easy example like methane, CH4 plus oxygen releases CO2 and water and heat and light. So now to balance this equation, so the common result when we burn a carbon compound in air is the production of carbon dioxide and water and the release of heat and light. Taking another example of ethane. Again, now balancing it here.
So today I'm going to explain about the oxidation reaction of carbon compounds. Now here an alcohol, when it is oxidized in the presence of alkaline potassium permanganate or acidified potassium dichromate, a carboxylic acid is formed. A respective carboxylic acid is formed. Now I'll explain how it is. Now we can take an example. Now we can take a really familiar alcohol, that is C2H5OH. Now do you know which alcohol it is? It's like, it is ethanol. It's a really familiar one. Now it is oxidized in the presence of, we can either take alkaline KMnO4 or acidified potassium dichromate. So I'll take here alkaline potassium permanganate. I'll use it short form here, okay? And we should provide heat also. Now here we have to make ethanoic acid. Now what is formed is ethanoic acid. It's like this. This is having two C's, so it is, the word root is eth. Then it's a carboxylic acid, so it is ethane, then oic acid. Okay, so here there are two carbon atoms, so it is ethane. Then since it is a carboxylic acid, we will write oic acid. Now I'll explain this with the help of the structural formula. Now this is how we write the ethanol in structural formula. C2H5OH. Now here what happens is, we are giving one oxygen and removing one hydrogen. But at the same time we have to balance the bonds also. So when I replace the hydrogen with the oxygen, now since with always with oxygen there should be a double bond. You know the reason. Now here if you look at the carbon, there are 5 bonds. 1, 2, 3, 4, 5. So that will not do. We have to dot this edge and it's like CH3 COOH, which is ultimately ethanoic acid.
Today I am going to explain addition reaction. As the name says, addition reaction is adding a hydrogen molecule to an unsaturated hydrocarbon such that it becomes a saturated one. So, for example, CH2 double bond CH2 plus hydrogen give you C2H6. An important point in this is that there's a catalyst that can be either nickel, platinum. This is addition reaction that is from an unsaturated hydrocarbon and alkene to a saturated hydrocarbon that is an alkene. Now, if, for example, it's a alkyne, like a triple bond CH, triple bond CH, plus hydrogen, this will only give you CH2 double bond CH2. The next step, we have nickel, then nickel and plus hydrogen molecules will give you C2H6.
Hello. Now I am going to tell you about the last and the fourth reaction of the carbon compound, which is a substitution reaction. Now let's take the simplest alkane for example, that is methane CH4. Now we have chosen here to take Cl as a substituent. Now please note that the substitution reactions can only occur in the presence of sunlight. Now what actually happens in substitution reaction is the one hydrogen atom gets replaced by Cl atom. So the product here will be C will remain as it is. There's one hydrogen loss that will be placed B and it gets replaced by Cl. Now we have got one hydrogen atom from here and one Cl atom from here. So these two also react together to form an acid, and that is HCl. Now if we take this as Br, the acid will be HBr. So now the process doesn't end over here. Now we take that compound CH3Cl and again it undergoes substitution reaction. This keeps on occurring till there is no hydrogen atom left to be taken out. So the product would be CH2, Cl2. Now we have to again make the same reaction because we see that there are two more hydrogen atoms left to be used. Now we see that there is another one hydrogen left to be taken out, so again the reaction occurs. Now we cannot continue this process further because we see there are no more hydrogen atoms left to be taken. So this is the final compound, which is known as carbon tetrachloride. And this CH3 is chloroform. That's all about the substitution reaction.